guys! So yesterday in class we set up the osmosis experiment and you had two cups. You had cup A and you had cup B. Right now we're going to focus on cup A and you should have this already in your notebook. If you weren't here yesterday and you don't have this in your notebook, we are on page 100 and you can get these notes from someone who is sitting at your table because you worked in table groups yesterday. So we're going to look at cup A first. As a review from yesterday, in cup A, you had the cup filled with distilled water. We put 100 milliliters of it in there. We labeled it as distilled water. And then in your dialysis tube bag that you tied off yesterday, you filled it with a mixture of distilled water and syrup that you would put on your pancakes. So we labeled those two things in our drawing. We have our distilled water. Our distilled water has a high amount of water, so it's a high water concentration. It also doesn't have any syrup in it, so we can say that it is a low solute concentration or a low syrup concentration. Remember, pancake syrup is full of sugar, and solutes are something that can dissolve in water. So your pancake syrup, full of sugar, that sugar is dissolved in the water mixture that we created. In the bag of dialysis tubing that you created yesterday, we have a mixture of distilled water and syrup. We can say that the bag has a low water concentration compared to the beaker because there is less water in the bag than in the beaker. And we can say that the bag has a high solute concentration or a high syrup concentration because there is more syrup or sugar, in this case, in the bag compared to in the beaker. Yesterday, before you put your bag of syrup water into your beaker, you took the mass of it using a digital balance. Your mass may or may not have been the same as mine. The mass of my bag of syrup water was 4.6 grams. You should have the mass that your group took here, but I'm going to use mine as an example. So, at the beginning of class today, you took the mass of your syrup bag after it had been sitting for 24 hours. So now we're going to fill in the after portion of our notes. If you noticed, the syrup stayed in the bag, none moved into the water in the cup, but something changed. So we're going to make sure that we go through and relabel our picture first. There's still water in the cup, so we're going to redraw water in the cup. And there is still syrup in our dialysis tubing bag. So we are going to redraw the syrup in the dialysis tubing bag. We're going to relabel both of those as well. So in our cup, we still have the same distilled water. And in our dialysis tubing bag, we still have our distilled water mixed with syrup. What we did was we took the mass of this dialysis bag full of syrup water on the digital balance after 24 hours, and we recorded that new mass. Remember, your mass is not going to be the same as my mass, So you need to write down your mass in grams that you recorded when you weighed your dialysis bag full of syrup water. My mass was 7.9 grams. Based on this, if we look at the mass at the beginning of our experiment and compared it to the mass at the end of our experiment, what did you notice happened to the mass? Hopefully, you noticed that the mass increased. If your mass did not increase, it's okay. Things go wrong in experiments all the time. Something could have gone wrong. If it didn't increase, don't worry about it. Still record your mass. We're going to talk, though, as if all of your masses had increased from the start of the experiment to the end of the experiment. If your mass did increase like it was supposed to, then we're all good. Based on your observations in your after experiment, what did you notice about the inside of your dialysis tubing bag full of syrup and water? Pause the video, go ahead and take a second, and talk to the people at your table. What you hopefully talked about at your table, and what you should have noticed if the experiment worked correctly, is that this dialysis bag full of syrup and water is more full than it was at the start. So we can write that the bag is more full, which would make sense because our mass increased from the start to the finish. Something else that you might have noticed is that the color of the syrup water in the dialysis tubing bag is lighter than it was at the beginning of the experiment. Color of syrup water in bag is lighter. Go ahead and think about this for a second. Based on these observations and based on an increase in mass from start to finish, talk at your table. Where do you think that mass came from? Pause the video. All right, I hope you've had a chance to talk about where you think this mass gain has come from. What did you guys think? Did you think that the syrup got heavier over time? Or did you think maybe that water from the cup moved through the dialysis tubing into the baggie? If you thought the second one, you're correct. That water in the cup moved from an area of high water concentration, going back to our first picture, in the cup, to an area of low water concentration in the dialysis tube bag. Or another way you can think about it is that water moved from an area of low solute concentration or low sugar concentration to an area of high solute concentration or high sugar concentration. So in our before picture, we're going to draw an arrow from the water in the cup into the dialysis tube bag. And at the blunt end of the arrow, so not where the arrow is pointing, we're going to write H2O to show that water is moving from the cup into the dialysis tube bag. Turn and tell your neighbor at this time, by what process does water move? Hopefully, you all said osmosis, because water does move by osmosis. Now that we've had a chance to kind of talk through everything, in just a second, you're going to pause the video, and I want you to turn and talk with your table. Come up with a summary, one-sentence summary, for what happened in cup A. Go ahead, talk at your table now, pause the video. Hopefully you had great on-task conversation at your tables about what happened in cup A. We are going to write down together in our ISNs on page 100 what actually happened in cup A in a nice, succinct summary. So, in cup A, you should have noticed that water diffused by osmosis from the cup through the dialysis tubing and into the syrup water, causing the bag to gain mass. Go ahead and pause the video for a chance to write this all down. All right, now we're going to look at cup B. Cup B was a little bit different than cup A. In cup B, the cup was filled with 100 milliliters of syrup and distilled water mixed together. So it had kind of that syrupy color. Inside of the dialysis tubing bag in cup B, we had just distilled water. So, as a reminder, our distilled water and syrup mixture is a low water concentration because there's less water in the cup compared to in our dialysis tubing bag. In our distilled water and syrup, there is also a high solute or syrup concentration, and that's because there's more syrup in the cup rather than in the dialysis tubing bag. If we focus on the dialysis tubing bag, we're going to notice that it is a high water concentration compared to the beaker because it's just water in the bag and there's no syrup. And inside of our dialysis tubing bag, there is a low solute concentration or low syrup concentration because there is literally no syrup inside of that bag. At the beginning of our experiment, and remember this number is mine because it's my experiment and you all did your own, my dialysis tubing bag full of distilled water weighed 4.8 grams. Yours probably weighed something different or similar to 4.8 grams. You would have had this written down from yesterday. After our experiment sat for 24 hours, you came back and you took the mass of your dialysis tubing bag filled with distilled water. We need to relabel everything in our diagram and make observations about it. Did you notice any change in color or amount of syrup water? Not really. So we're going to redraw that syrup water. Did you notice any change in color of the distilled water in your dialysis tubing bag? Still the same color, water, no color. So we're going to redraw our water in our dialysis tubing bag. We want to make sure that we relabel it as well. So we still have in our beaker distilled water and syrup. in our dialysis tubing bag, we still have just distilled water. At the beginning of class today, you guys took the mass of your dialysis tubing bag filled with just distilled water. At this time, I'm going to have you fill in that mass in grams next to your after picture. My mass after letting it sit for 24 hours was 2.9 grams. What observations do you have or do you notice about your dialysis tubing bag filled with water from the previous day? How has it changed? Go ahead and talk at your tables for a quick second. Hopefully you noticed that the bag looks like it has lost some of the water, or the bag looks maybe deflated. So we're going to write that observation down. Comparing our before mass to our after mass, which as a reminder, your masses are going to be different than mine because we each did our own version of the same experiment, and there will be some variation, which is okay. You should have noticed that the mass from before is greater than the final mass. So overall, the mass decreased. If your mass didn't decrease, it's okay. Experiments are not always perfect the first time we do them. So if your mass increased or if it stayed the same, don't worry. You should have seen, and we are going to talk about this experiment as if your mass had decreased. I would like for you guys to turn and talk at your tables about why you think the mass decreased. Go ahead and pause the video. Hopefully you've had a chance to have a good discussion about why you think the mass decreased in our dialysis tubing bag after 24 hours. Hopefully you guys mentioned that in cup A, the bag gained mass because water moved into the bag by osmosis. If you use that same concept and apply it, in cup B, you should have come to the conclusion that the dialysis tubing bag lost mass because water diffused out of the bag by osmosis. So, in our before picture, we're going to draw an arrow coming out of the dialysis tubing bag. And we are going to label at the end of that arrow H2O for water. And so this is showing us that water is diffusing out of the dialysis tubing bag by osmosis. I want you to take a second, turn to the people at your table, and just like we did for cup A, I want you to come up with a succinct one-sentence summary for what happened in cup B. Go ahead and pause the video. Hopefully you had a good conversation at your table summarizing what happened in cup B. As a reminder, in cup B, water moved from an area of high water concentration inside the dialysis tubing bag to an area of low water concentration inside of the cup which had syrup water in it. You can also think of this as water moving from an area of low solute or sugar concentration to an area of high solute or sugar concentration, which is in the cup. Remember, just like with diffusion, osmosis wants the same goal to happen at the end, to reach equilibrium, to have all of the concentrations on either side of our partially permeable membrane, in this case the dialysis tubing, to be approximately the same or equal. So we're going to write our summary for cup B. In cup B, water diffused by osmosis from the bag through the dialysis tubing and into the syrup water in the cup, causing the bag to lose mass. Go ahead and pause the video at this point so that you can have a second to write this down in your notebook. At this point, you are probably out of space on page 100, writing the summaries and the diagrams for cup A and cup B. So we are going to switch over to page 101. At the top of page 101, I would like for you to write what happened, because here we're going to summarize what happened in osmosis. Try not to use the entire page, so maybe mark off the halfway point on that page with a line straight across, because when I'm back on Tuesday, we are going to do a little bit of math on the bottom half of that page to calculate percent change. All right, now that we've talked about what happened in cup A and cup B in our osmosis experiment, we are going to summarize osmosis as a whole, because osmosis happens the same way in all sorts of different experiments and even in your body, as you read in the hyponatremia article that we discussed yesterday in class. So, as a refresher, we know that the dialysis tubing is permeable to water. We also know and can conclude from the experiment that water diffuses by osmosis from an area of high water concentration to an area of low water concentration. Another way that you can think about osmosis, instead of thinking about areas of high water concentration and areas of low water concentration, is you can think about the solute concentration. Again, a reminder, solutes are substances that diffuse in water. So if we're thinking about osmosis in terms of solute concentration, water is going to diffuse by osmosis from an area of low solute concentration to an area of high solute concentration. Ultimately, as a reminder, with both osmosis and diffusion, we want the concentration of whatever is diffusing to reach equilibrium, which means those particles, whether in the case of osmosis it's water, or in the case of diffusion it could be a particle or a molecule, to be evenly spread out in whatever space they are in. Go ahead and pause the video to make sure that you have this written down. You guys do have homework today. You have the osmosis practice worksheet. There are 3 questions on here. One question has several parts. The first question is asking you to define osmosis. As a reminder, if a question asks you to define something, It wants the literal definition. So please check your notebooks. On page 83 and 84, you should have the actual definition of osmosis in your notebook. The second question is asking you for two differences between osmosis and diffusion. Go ahead and look at your notes on both your osmosis and your diffusion experiments, but also look at the definitions of osmosis and diffusion. Just from the definitions, I'm sure you'll be able to find two differences very easily. On the last question, you see a bunch of beakers and circles inside of the beakers. The circles can be similar to the bags in the experiment that you just did, and the beaker is just like the cup in the experiment that you just did. Your job is to draw an arrow in each beaker, either pointing into the circle or out of the circle, depending on which way water is moving. Remember, water is always going to diffuse by osmosis from an area of high water concentration, where there's more water, to an area of low water concentration, where there's less water. Or you can think about it in terms of solutes. Water is going to diffuse by osmosis from an area of lower solute concentration to an area of higher solute concentration, because it's ultimately trying to water down that higher solute concentration to even out the concentrations so that we can reach equilibrium. There is a couple of beakers on that page where everything is equal and everything is already at equilibrium. Does that mean water molecules have completely stopped moving? Hopefully you thought no, because water is always in constant motion. It just means that the water is moving back and forth through the barrier, which is in this case a partially permeable membrane, like a cell membrane, at an even rate. So in that situation, you're going to draw one arrow into the circle and one arrow out of the circle. You then need to go through all 9 of those beakers, and you need to identify which solution in the beaker or in the circle is more concentrated. The more concentrated solution is going to have a higher percent of solutes. So you need to highlight or circle which concentration is more concentrated, which one has a higher concentration of solutes compared to the other one. And then the last thing, there are a couple of beakers on there that are already at equilibrium. You need to circle those beakers that are at equilibrium. This worksheet is going to be due on Tuesday when I am back. Just a reminder, I'm also gone on Monday, so please be good for the sub. I love you guys and have a great weekend.